Okay, in this section, I'll give you a preview of percents on the first page, just basically pulling out percentages from a table, as you see here in example 1. And then on the second page, I'm giving you a preview of Simpsons Paradox. Okay, so I'll talk more about that on the second page. All right, so in this first example, it says this is giving you information regarding a manufacturer of cars driven by people who were interviewed. So you can see here you've got car and SUV owners, and then they were choosing among Ford and Toyota. So you've got, 55 people chose a Ford car, 30 people chose a Toyota car, for a total of 85 people that chose cars. If you follow the columns down, 55 chose a Ford car, 28 chose a Ford SUV, so a total of Ford owners, 83. So just to kind of giving the lay of the table up here. This 130, if you were to add straight down this way or add straight across this way, you'd get the same number, and which would be 130. And what that does is that just represents the total amount of people that were interviewed and answered the survey. Okay, so I'm just going to do 3 of these here in this first example. It says in part A, what percent of all respondents drive a Ford SUV? So think about this, your total number of people, because it says all respondents, so the total number of people, that's going to be your whole. And then your part's going to go up top and then times 100. So it's going to be part over whole times 100. So I want to know then how many, looking up in the table, how many drive a Ford SUV? And so hopefully you would agree with this number right here, 28. So you would put in your calculator 28 divided by 130 times 100 to get you a percent. And we'll just round everything to the nearest tenths place. So I would arrive at 21.5% final answer. Okay, I'm going to scoot on down then to part D. It says, well, actually, I'm going to do D is the same. Let's do C. It says, among the SUV owners, what percent of the drivers owned a Ford? So among the SUV owners, so that means that's your bottom number. So total SUV owners. So here's your SUV line. To get total SUV, you've got to follow it all the way across. So that would be 45. How many of those owned a Ford? And so we know, okay, well, there's 28 Ford SUV owners. So you've got your 28 over 45 times 100, and that should put you at 62.2%. Okay. And then let's do E. E says, among the Ford owners, so that's going to be my denominator, how many total Ford owners do I have? So looking up here in your table, you get total amount of Ford owners. You've got to follow it all the way down. That's the 83 here. So put that on the bottom. What percent drive a car? So that was 55 up there for driving a car, right here. So then I have 55 over 83 times 100, and that should put you at 66.3%. Okay, and then we'll look on down here at letter G together. And it says here, which is more prevalent, meaning which happens more often, car owners among Ford or SUV owners among Toyota. So car owners among Ford, that's what we just calculated. That's our 55 out of 83 times 100, and we just found out, okay, that's 66.3%. Now this other one over here, we've got to actually do some work. SUV owners among Toyota. So since it says among Toyota, that's going to be, excuse me, my denominator. So how many Toyota owners do I have? And hopefully you would agree that's 47. SUV, how many SUV owners for Toyota? 17 times 100. And that should put you at 36.2%. And so clearly then, car owners among Ford is more prevalent because that's the higher percentage there. Okay, I'll let you try letter H and finish up this page here. All right, so let's flip it on over then to the next page, and let's look at Simpsons Paradox. And Simpsons Paradox occurs when a set of data is evaluated in 2 separate manners and yields differing results. Okay, so here it says the high schools in a particular state gave a math proficiency exam to its students and reported the results as a result of their socioeconomic status. So you have low-income results and high-income results that are reported here. Local schools versus state schools. So they've got the number of students who passed, the number of students who were tested, and then they want the percent that were passed. So of our local schools, if I want to get the percent that were passed, then I know the number that were passed, that's my part, over the total number that were tested. So in my calculator, I would be doing, get this a little bit smaller here, I would be doing 260 divided by 400 times 100. And we'll just do, let me see. Okay, we'll just do nearest whole number. If you ever have to round, I just do the tenths place. It'll be good. So then that puts you at 65%. All right, so on the next one, if I want the percent that passed from state schools, I would have 128,000 that passed out of the total number that took it, 200,000. Put that in our calculator. And that should put you at 64%. Okay, and of course, you're still always multiplying by 100. I just didn't write it there. There we go. All right, so high income results for local schools, 532 passed out of 700 that took it. So 532 divided by 700 times 100. And then that should put you at 76%. And then the last one, 825,000 divided by 1,100,000 times 100, and that should put you at 75%. So now we've got, looking at these results here, first question says, which results showed a higher pass rate among those who had lower income? So your lower income is the top table up here, and you just would compare these two values here. Okay, so 65% of course is the larger percentage there, and that corresponds to local schools. Which results had a higher pass rate among those who had higher income. So here's your higher income. That's the second table here. Again, we're looking at these two percentages here, and looking for who had the higher percentage. Local schools again, 76% is higher than 75%. So broken down here by high income and low income, we're seeing that local schools had the higher pass rate. Now, if we try to put the data together as an overall pass rate for local schools versus state schools. So in here, I didn't fill in the table for you, but we can fill it in with the numbers that were given to us. We know that 260 passed low income, 532 passed high income. Add those two together. Let me get my pen. So it would be, you would be doing here 260 plus 532. And that would put you at 792 students. Then to get state schools number of passed, you're going to take your 128,000 plus your 825,000. So 128,000 plus your 825,000. I'm just going to put this like in parentheses here because these numbers, I'm just trying to show you where I got them. That should land you at 953,000. Okay, total number of students that were tested. So this first one's going to be 400 plus 700. Looking at these two values here, and so that's going to put you at 1,100. Total number then for number of students in state schools, 200,000 plus 1,100,000 will put you at 1,300,000. Okay. So now if you want the percent that passed here, same thing. For my local schools, it's going to be 792 divided by that 1,100 times 100, and that's going to put you at 72%. And then on the bottom one, you're going to have 953,000 for your state schools divided by 1,300,000. Still times 100, so we get our percent. That should put you at 73.3%. So now if we answer the question here, which group had the overall higher pass rate, local or state schools? And if we're looking at, again, here, 73% is definitely higher. So now overall the data is showing that state schools had the higher pass rate. This is an example of Simpsons Paradox. It's the same data, it's just it's organized differently. Up top it was organized by income status, and on the bottom everybody all together showed different results. So we would say that yes, get down here so I can write. So we would say yes, because when the data is separated. And I always ask that whenever you're doing a Simpsons Paradox problem that you always speak in terms of the problem. As I'm going to ask you this on the test, I'm going to ask you to explain. I ask you to speak in terms of the problem. Don't just say yes because one way showed one result and the last table showed a different result. I want you to speak in terms of the problem. So yes, because when the data is separated by income, it showed that local schools had a higher pass rate. This course is called Quantitative Literacy, so there is a little bit of writing involved in this problem in this course. However, overall, the data showed that state schools had a higher pass rate. And that's an example of Simpson's Paradox. Okay. Again, always speak in terms of the problem. Let me know if you need anything. Thanks a lot. Bye.